Hi guys, welcome to D&M's final team teach. This is going to be a review over chapters 1 and 7 for Math for Teachers 1 during the summer. I'm Miranda Curtis.
And I'm Laquila Roberts.
Okay, let's get this rolling. See, it's actually rolling.
Ooh.
Okay, Miss Dominique, place the digits 8, 10, 11, 12, and 13 in the circles to make the sum across and vertical equal 31. Is there more than one answer to the puzzle? Show a possible combination of numbers to prove how many combinations exist.
All right, so as you see, for our question 1, we have 12 plus 8 plus 11 equals 31. 10 plus 8 plus 13 equals 31. Okay, so here we go. Check that out. So we have 12, 8, and 11. That's straight up. And then we have 10, 8, and 13 across. So the two combinations, there we have it. So Miranda, complete the following puzzles.
Okay, so we have our example that's coming up. Come on, example. Okay, so our squares, we're going to complete our puzzles. So this is how we're going to start up here in our example. 2 plus 8 equals 10. We're going to go from the top, and it's going to give us our middle. Then we're going to go 5 plus 3 equals 8. Right here, we're going to go to the bottom and go to the side, and again, it's going to give us our middle. Then we're going to go 2 plus 5 equals 7. We're going to come from the top and go to the bottom. It's going to give us 7. Then we're going to go 3 plus 8 equals 11. So we're going to go bottom to top, and that's going to complete our square. So how we're going to get our missing bubbles over here is we're going to subtract what they give us. So we're 7, 15, 20, 17, and 12 we're given. We must find what the green circle is going to give us. So 7 plus 8 equals 15. And when they give us 15, we're going to do 7 minus 15. Okay, to get our next bubble, we had 5. So 5 plus 12, which is our little bubble down here, is going to give us 17, which is going to be right there. And then 12 plus 8, right here, is going to give us 20. Now, in our B, we have 6, so our next bubble is 7. So 7 plus 6 equals 13. Then we're going to do our bottom one. Set 4 plus 15, there it goes, equals 19. 7 plus 4 equals 11, and then you're going to do 15 plus 6 equals 21. So, Miss Dominique, complete the following puzzle. It is coming up next to you.
All right. As Miranda was just told us on our last one, we're going to do the exact same thing, okay? So what you're going to do here, with C, we're going to do 9 and 5 gives us 15. 9 and 3 gives us 12. 3 and 3 gives us 6. And 5 and 3 gives us 8. So that's no solution, all right? Our next one is 1 plus 6 equals 7, as you see here. And then we have 8 plus 10 equals 18. And then we have, sorry, come on, curtain. Then we have 1 plus 8 equals 9, and 10 plus 6 equals 16. So that's how you solve that. All right, Miranda. 9 square tiles are laid out on a table so that they make a solid pattern. Each tile must touch at least one other tile along an entire edge. See the 2 examples on the right. The squares all have sides of length 1. So question 2, can you answer this for us?
Yes, ma'am. So we're going to sketch all the possible perimeters with 9 squares. So perimeter means it's going to be all around. So in our first one, we have 1, 2, 3. So it's going to be 3 on that side. 1, 2, 3. 3 on this side. And 3 on that side. And 3. And that will give us 12. Now our next one, there it is. I'm making sure one of the bubbles doesn't jump somewhere. 1, 2, we have on this side. On the top, you have 1, 2, 3, 4. And then this side counts 5, 6, 7. So you have 7, well, 6. And then you have 1. And then that's going to give you 14. Now, our next one, our possible parameter, is 16. So we're going to do 3 on this side. And you're going to do 1, 2, 3, 4, 5 right here. You're going to do 3 and 5 on the bottom. It's going to give you 16. So, yeah, there he goes. Okay, so our 18, we're going to do 2 on the bottom, 1 on the top, and it's going to be 1, 2, 3, 4, 5, 6. And then on this side, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to give you 18. Now, our biggest one right here is going to be 20, and they're all touching. You know, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 and 9, 1 and 1, which gives you 20. So all possible parameters are going to be 12, 14, 16, 18, and 20. So, Miss Dominique.
I like how you did that. I really did.
Thank you. If you wanted to be more hands-on, you could have your own little green squares in hand, and you can sit there and play with it and gives you a better hands-on experience. Ms. Dominique, 9 square tiles are laid out on a table so that they make a solid pattern. Each tile touches at least one tile along an edge. See the 2 examples on the right, and they each have 1 length. Okay, Ms. Dominique, can you solve B for us, please?
Yes. All right, so question 2B. As you see, we have our squares. And as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, yeah, 3, 3, 6. 3 on each side, 3 on the left, 3 at the top, 3 on the right, and 3 at the bottom will give us 12. Our next one is, we have the greatest of 20, all right? So as you can do, is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 on each side, plus 1 on the top and the bottom will give us 20. So our least is 12, our greatest is 20. All right, Miranda, question 3. The figure to the right shows an addition pyramid in which each number is the sum of the numbers immediately below. For each of the incomplete addition pyramids, show that the values in each square can be determined by forming and solving an equation in the unknown variable shown. Write an equation to solve each pyramid. Show each step used to solve each equation.
Okay, so we have an example additional pyramid up here, and we have 3 plus 5. That's going to, it should light up. There it goes. 3 plus 5, and that is going to give us our square above it, which is going to give us 8. And then we're going to do 5 plus 4 gives us 9. Now our next 2 squares, 8 and 9, are going to give us 17, which is going to give our top. So that is how we're going to start with problem A. We're given 25, x, 7, and 3. When the x is in front, that means we're going to plus. So our equation is going to be x plus 7. Okay, come on, Bubbles. Okay, x plus 7. 7 plus 3 equals 10. And then if you minus 10 from 25 is going to give you 15. So therefore, you're going to have all of these. So x has to equal 8 because 8 plus 7 equals 15. Now, our next one, there it goes. Okay, so y is behind the 1. We're still going to plus because it's in the bottom. So our equation is going to be 1 plus y. Now we're going to go next to it, and we're like, okay, there's y plus 2. So what we're going to do is we're going to have 15 minus 8, and we're going to get our 15 minus 2 gives us 8, and we're going to have 8 right there. And then 8 plus 7 equals 15. How we find y is we do 7 plus 1, and that will give us 7 minus 1, 6, gives us 1. We're going to get there. Our pyramid squares is just as it follows. 6 plus 2 equals 8, 1 plus 6 equals 7. Okay, Miss Dominique, the figure to the right, that's on the left, shows an additional pyramid in which each number is the sum of 2 immediate below. For each of the incomplete addition pyramids, show the value in each to the unknown variable shown. Write an equation to solve each pyramid.
All right, so question 3, module 1, 4C. So we have our 3 plus 5 will give us 8, and 5 plus 4 will give us 9, and 8 plus 9 will give us 17. That's our example. So how we would do this is to find z, that's minus 2. So we'll do 10 plus 17 will give us 27. 10 minus 2 will give us 8. 2 plus 8 will give us 10. 8 plus 9 will give us 17. So as you can tell, z is our 10, okay? Real easy.
Good
All right,
job.
Miranda.
I like how you wrote that down.
Yeah. Consider the trapezoidal numbers 1 plus 1 plus 1, 1 plus 2 plus 2 plus 2 plus 1, 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. The nth trapezoidal number is 1 plus 2 plus, and so on and so on. Whereas n is a positive integer.
Okay, Ms. Dominique. So we're going to take the first 1 plus 1 plus 1. So we're going to create a dot pattern to represent the trapezoidal numbers. That way it's easy to look at. So we have 1 plus 1 plus 1 equals 3. What we're going to do is we're going to put a dot above the number of how many it is. So we have 1 dot. And we're going to go to the next spot, and it's going to bring us another dot. And then we're going to have another dot. So 1 plus 1 plus 1 has 3 dots. So our next one is 1 plus 2 plus 2 plus 2 plus 1 equals 8. We're going to do the same thing. We're going to have 1 dot above, and then we're going to go above 2 and put 2. Next is we're going to put 2 more up, and then we're going to go to the next 2 and put 2, and then we're going to put 1 dot above, and that's going to give us 8. If you count them, it will give you 8. Now our next one, it looks really hard, but it's really not. 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 equals 15. So again, we're going to do the same thing that we just did over here. We're going to have put 1 dot above, then we're going to, above the 2, we're going to put 2 dots, above the 3, 3 dots, above the 3, 3 more dots, 3, 3, and 2, 2, 1. So that is going to give us 15, and that gives us a cool pattern too.
All right. Great explanation.
Miss Dominique. Okay, now we're going to go to question 4, mod 1, 6b. Notice that 1 plus 1 plus 1 equals 1 times 3. 1 plus 2 plus 2 plus 2 equals 2 times 4. And 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 equals 3 times 5. Show how the dots in a representative trapezoidal number can be rearranged into a rectangle with 2 more columns and rows.
All right. So as you can see here, 1 plus 1 plus 1 equals 1 times 3. So that gives us the 3 sons, okay? Our next one is 1 plus 2 plus 2 plus 2 plus 1 equals 2 times 4. That gives us a little lightning bolt. 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 equals 3 times 5. So it's 3 here and 5 across. So that's how you will figure that. That's just like 2 to the 4. So that's 3 to the 5th. 1 to the 3rd. Woo! Check it out. All right, Miranda, it's your turn. Question 5, Module 2, 1A through C. Locate all the elements of U in the Venn diagram. Let U equals A, B, C, D, E, F, G, H. A equals B, C, D, G, H. B equals D, F, H, and C equals D, G, H.
Okay, so what we have to understand is the square U means everything in the square. So ABC is all in the square. So the first thing we're going to do is we're going to find A. So A is only in U, so it's going to come over here and it's going to only be down here. It's not going to be in the bubbles. Okay, then next we're going to look for B. B is only in A. It's in U, but it's in A. So it goes in the A bubble. Then we look for C because we're going to go A, B, C. And C is only in A, so it's going to go in the A bubble. And then our next one is E. E is only in U, so he's going to come out here with A. And then we have F, and F is in U, it's in B, so it goes in the B. Okay, and then our next one is G. G is only in C, so he's going to come down here. And then H and D are in A, B, C. They're going to go right here and they're going to intersect. Okay, so our question says, list the elements in this set B. The U stands for union. And if we look over here in our help bubble, it means that it's in both sets of numbers because these little wiggly things, that means it's in a set. So we're looking for B union C. So what's it going to give us? It's going to give us D, F, G, and H. Okay, our next one, list the elements in this set A, and we're going to look over here for our N right there. And what this one means is the symbol means that they're in both sets. So it intersects. So it's not like our U. It's not going to, no, I got it backwards. It means that it's going to be one or the other. So A and B. So the only ones that intersect with everybody is H and D with A and B. So our last one right here is list the elements in the set B, and we have our N and our C. So that means it's going to be B and it's going to be C. So there's only two. So it's going to be D and H. Okay, let's see. So Miss Dominique, we're going to go to question, it's still question 5, but it's mod 2.1 first question, D through F. Locate all the elements in U in the Venn diagram. Let U, A, B, C, D, E, F, G, H be in U. A is B, C, D, G, H. B in set D, F, H. And C set D, G, H.
All right. Here we go, our diagram. It's right here with all the different letters that we're going to be looking at. Okay, so we're going to list the elements in the set A and C. So that will give us AC equals B, C, D, G, H. B, C, D, G, H. We're going to list the element in the set of A. So that'll be everything. And that's going to give us A, E, and F. We're going to list the elements in the set A and C. A, C. And that's going to be D, G, and H. We're going to list the elements in the set A and B and C. And you're going to get D and H, just these two right here for that one. Okay. Miranda, question 6, mod 2.2, A and B. The Venn diagram shown to the right with attributes described by shape, size, and color Let CH and T denote the sets of circular, hexagonal, and triangular shapes, respectively. Let SLR and B denote the sets of small, large, red, and blue shapes, respectively. The set A contains the shapes that are small and not a triangle. So A equals S or T, complete parts A through D. So, but you will do A and B.
Okay. So we have our little review bubble over here. It's going to be just like our other ones, except we're looking at objects. So it says demonstrate which shapes are found in the set L, and then we have our little signs and H. So what we have, L stands for large, H stands for hexagon. So then we have B. Demonstrate which shapes are found in the set C, and we look at the U over here, it means or. So we have circular or hexagon. Okay. I love when it didn't light up. That's okay. I love when we have shapes instead of letters. Okay, Ms. Dominique, we still on question 6, mod 2.2, C through D. The Venn diagram shows to the right attributes described by the shape, size, and color. We have C, H, and T denotes the set of circular, hexagon, triangle shapes, respectively. Set L, R, and S, and B denote the set of small, large, red, blue shapes, respectively. The set A contains the shapes that are small and not a triangle, so A, S, and T with the apostrophe completes C through D.
So here we go. We're going to demonstrate which shapes are found in the set T and R, all right? So that means not triangles that are red. And then our next one, we're going to demonstrate which shapes are found in the set C and S and R. And we're going to get circular or small and red. All right, Miranda. Question 7, mod 2.4, A through B. Lattice multiplication.
Okay. We're going to do some lattice multiplication. Yay. So we have multiplied 28 by 32. So our little box is going to come up, and we're going to put a 2 in one column and an 8 in the other. Then we're going to go down the side, and we're going to do a 3 and a 2. They like to pop up on their own. They have free spirits. Okay, so then we're going to get to multiplying. So 3 times 8 is 24. We're going to put a 2 up top and a 4 down the bottom. Then we're going to go 3 times 2 is 6. Make sure you use your 0. Put your 0 up top and the 6 on the bottom. We need those zeros to add. Okay, then we're going to go to the bottom. We're going to go 2 times 8 is 16. We're going to put a 1 up top and 6 at the bottom. Then we're going to 2 times 2 is 4. So you're going to do 0. Then you're going to do 4. Now we are going to add. So first, we're going to bring down our 6 right here in our square. Then we're going to do the next one. And we're going to do 4 plus 1 plus 4, and that gives us 9. We're going to bring it down. And then we're going to come up here and go 2 plus 6 is 8. And we're going to bring that down. And you're going to bring 0. Now, what's really cool is if you go around your square, it's going to give you your answer. So 896 is our answer because 28 times 32 equals 896. Now it works with bigger numbers too. So our B is multiplied 273 by 628. So again, we're going to give them each their own spots. We're going to have 2 up top, a 7, a 3, and then it's going to go down the side. A 6, a 2, and an 8. Now we're going to start multiplying. So 6 times 3 is 18. Put 1 up here and 8 on the bottom. 6 times 7 is 42. Put your 4 up here, your 2 on the bottom. 6 times 2 is 12. Put your 1 and your 2 on the bottom. You're going to go down. 3 times 2 is 6. Remember your 0. And then put your 6 on the bottom. 7 times 2 is 14. Put 1 up top and 4 on the bottom. And then 2 times 2 is 4. Remember your 0 again. put your 4 on the bottom. We're going to go down to our last row. 4 times 3 is 24. Put your 2 down here and your 4 on the bottom. And you do 8 times 7 is 56. Put your 5 up here and your 6 on the bottom. Then here's our last square. 2 times 8 is 16. So you're going to put 1 up here and your 6 on the bottom. Now we're going to add. So you're going to bring down your 4, and then we're going to go to our next spot. So 6 plus 2 plus 6 equals 14. You put 4 up here, and then you're going to put your 1 up top to carry. So then we're going to do 1 plus 8 plus 0 plus 4 plus 5 plus 6, and that is going to give us 24, and you're going to put your 2 up here. And you put your 4 down there. Now we're going to go 2 plus 1 plus 2 plus 1 plus 4 plus 1, and that gives, where did the other letter go? It gives us 11. We have 1 down here, and the other one's going to pop up in a second because it likes to do that. And then we're going to go 1 plus 4 plus 2, and it's going to give us 7. And then we're going to bring down our 1, and that will give us 1,701.44. Okay, Miss Dominique, let's work on some more lattice multiplication.
All right, I don't know what happened with our names, but hey, we're going to keep it going. All right, so we're going to do 964 by 593. As you can see on our table here, 964 is going to go up top and 593 is going to go on the side. So we're going to do 3 times 4 will give us 12. 3 times 6 is going to give us 18. 3 times 9 is going to give us 27. Sorry, I started at the bottom, but hey, 9 times 4 gives us 36. 9 times 6 gives us 54. 9 times 9 gives us 81. All right, so we got 5 times 4 give us 20. 5 times 6 give us 30. 5 times 9 give us 45. So after you do that, you're going to do, we're going to bring down the 2. All right, and then we're going to add 6 plus 1 plus 8 plus 5 gives us 15, which you're going to carry the 1. And then you're going to do 1 plus 1 plus 0 plus 3 plus 4 plus 7 give us 16. And then you're going to do 1 plus 2 plus 0 plus 5 plus 1 plus 2 equals 11. 1 plus 3 plus 5 plus 8 equals 17. And then you got 4 plus 1 equals 5. Next, we're going to multiply 4,952 by 243. Same thing as we did with our last one. We're going to do 2 times 2 gives us 4. 2 times 5 gives us 10. 2 times 9, 18. 2 times 4, 8. We drop down to the second one. 4 times 2 is 8. 4 times 5 is 10. That's supposed to be a 1. Wait. 4 times 5 is 20. I'm sorry. My fault. 4 times 5 is 20. 4 times 9, 36. And 4 times 4 is 16. Our last one is 3 times 2 give us 6. 3 times 5 give us 15. 3 times 9 give us 27. And 3 times 4 gives us 12. So we did all of that. And we are heading to bring our numbers down. So we're going to bring 6 down because there's nothing with 6. We're going to do 8 plus 0 plus 5 gives us 13. We're going to do that 1 will come up there right there. So our next one we're going to do is 1 plus 4 plus 0 plus 0 plus 1 plus 7 gives us 13. We're going to carry that 1. So then we do 1 plus 2 plus 6 plus 2 plus 2 gives us 13. Carry another 1. 1 plus 1 plus 8 plus 3 plus 6 plus 1. It's going to give us 20. I'll carry that 2. 2 plus 1 plus 8 plus 1 equals 12. And then 1 plus 0 equals 1.
Miss Dominic, I love how you started at the bottom of the squares.
I know, right? Did a little different. Let's see if you were paying attention. All right,
It
Miranda.
worked.
Demonstrate rounding to the leftmost digit to estimate the results of each of the following expressions, then make the exact computation.
So what we're going to do, our problem is 883 plus 465 over 134. So what we're going to do is we're going to do order of operations. So it starts with my dear Aunt Sally. Multiply, divide, add, and subtract. So what we're going to do first is we're going to add. So 883 plus 465 is 1,348. We're going to bring down the 134 because it's not time to divide yet. Now it is. So when you divide this one to that one, you get 10.05. Now on B, we have our order of operations again. We have 5 times 254 plus 523 over 35 plus 7. So, my dear Aunt Sally. So, we're going to multiply first. So, 5 times 254 is 1,270. And you're going to bring down the 523. And you're going to bring down 35 plus 7 because now we're going to add. So, when you add 1,270 plus 523, you get 1,793. Then we're going to do the bottom. We're going to do 35 plus 7 equals 42. And then we're going to divide, which gives us 42.69. So, Miss Dominique, demonstrate rounding to the leftmost digit, estimate the results of the following expressions, make the exact computation.
Well, Miranda, do you mind just taking over this question again to get us back on track?
Surely. So again, we're going to do our order of operations. This time, we're going to multiply them because we have 620 times 430 over 293. My dear Aunt Sally. So when you multiply the top, you get 26,660, and there's a 0, over 293. And then we're going to divide, which gives us 909.89. Now we're going to
Thank you so much,
next.
Miranda. I don't know what happened, but we're going to get back on track.
Hey, we got this. Miss Dominique, can you compute the base of 5 and 6 for us?
All right, let me see what I can do for us. So 432 plus 133. As you see, we got 432 on here, 133 right here. And so we're going to have on 25, we got 4, 1, 2, 3, 4. On our 5s, we have 3, 1, 2, 3. And 1s, we have 2. For 133, we have 1 under 25, 3 under 5, and 3 under 1. So when you come down, we're going to add the dots to right here. So that's it should be 5 here. 1, 2, 3, 4, 5. 6 here. 1, 2, 3, 4, 5, 6. And 5 here. 1, 2, 3, 4, 5. So then you bring down and we're going to add it all together. So we got 1, 2, 3, 4, 5, 6, 7, 8. So if you look over here to this side, when we add 432 to 133, it gives us 621. But guess what else? 6 plus 2 plus 1 gives us 8. 6, 7, 8, 9. Okay? So check that out. Our next.
Remember, Miss Dominique, don't forget to circle your 5 so you bring over 1. So that'll
Yes.
give you your 5.
And you're correct. As Miranda says, circle them, take a 1. Thank you so much, Miranda. Our next one is 628 plus 73. I don't know what's going on today, but hey. And so for our 36, we got 6 dots. 6, we have 2 dots. 8, we have under our 1 dot, 1s. For 73, For 36, we have none. Under our sixes, we should have 7. 1, 2, 3, 4, 5, 6, 7, which we do. And our ones, we have 3. So once we come down here, we're going to add these numbers and bring them down. All right. So we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 that's down here. And 1, 2, 3, 4, 5, 6, 7, 8, 9 that's down here. And well, here looks like we should just have 6. So once we bring down what we need, what circle here, because 628 plus 73 gives us 745. So what circle here is our dots, but then we have to take some away to make some, you know, to move it around to equal it all out. Miranda, computing base 5 and 6. Question 9, mod 2.6, D through E.
Okay, so this is going to be a little bit different than when we add them. We're going to be subtract. Okay, so we're going to subtract 414, that's 5, from 43 fives. What that means when we say 5, excuse me, is when we subtract, when we normally subtract, you take 1. You won't be taking 1, you'll be taking 5. And the 6s do the same thing. So what we're going to do is we're going to start with our boxes. We're going to have, well, we're going to start with our numbers. We're going to do 4, 1, 4, and our boxes are going to come up. So we're going to have 25s, 5s, and then we're going to have 1s. And then the same thing for the 43. We're going to have 25s, 5s, and 1s. And what we're going to do is we're going to fill them in. So in our 25 spot, we have 4, so we're going to put 4 dots. In our 5th spots, we have 1. In our first ones, we have 4. Then we're going to come down here to our next ones. In our 5 spot, we have 4. 25, we don't have any. In our first spot, we have 3. So we're going to put 3 dots. So how we're going to solve this is because we had to borrow over here, we took 1 away from the 4 and left it at 3. And then what we brought over, we brought 5 over. 5. Not 1, we brought 5. So we're going to have to do 5 plus 1 is 6. And we're going to have to minus 6 minus 4. And that is going to give us 2. Our little numbers are catching up. But see, we're still going to do 4 minus 3 is 1. So it's going to give us 3, 2, 1. You see our little, there they go, they're spinning. So that is how we got that answer. Now we're going to come over here and we're going to subtract 503 5s or 24 5s. Wasn't expecting the wave. So we're first going to put our numbers up like we normally do. We're just going to use boxes and dots to help us. So in our first 25 spot, we're going to have 5 dots. In our ones, we're going to have 3. Why are they doing crazy? But they are. Okay, so we're not going to have any in our 5s. Okay, come on now. Okay, in our 24s, we're on our bottom, we're going to have 2 in the 5s, 4 in the 1s. Okay, so we're going to do the same thing like we did with the other one. Okay, so right here we have a 5, and then I don't know what it is. Well, so we had 503, and then we had 24. So what it was is we took 1 from the 5 because the 10 needed 1. So that left 5 plus 1, which makes 6. And then I know them curtains are tricky today. They are just flopping around. It must be windy outside. But we had to take 1 from the 5. So we're really taking 5. So that made 4 because then the 3 needed to take 1. So 4 minus 2 is 2. Put 2 dots down here. And then 5 plus 3, because remember we're taking 5, not 1. 5 plus 3 is 8, and we're going to do 8 minus 4 gives us 4. So it's going to give us 424. So hopefully we got all that. Hopefully that makes it a little bit easier. So question 10, mod 3, 2, A through B. Ms. Dominique, use the process of 9 to check each of the following.
All right, so as you see on alphabet A, 416, 7,490 plus 69,844. It says it tells us it's 1,100, no, 1,127,90. So let's see what it is. So we got 4 plus 1 plus 6 equals 11. 7 plus, with the remainder of 2. 7 plus 4 plus 0 equals 11, with the remainder of 2. 6 plus 8 plus 4 plus 4 equals 22, with the remainder of 4. And then you got 1 plus 1 equals 2. So, cast out 9, show there is an error. The given remainder is 2 and 4. The correct answer is 77750. Our next one, B, we have 8550, 6888, 2525, 6029. And we're going to add that up, and it's telling us it's 23,892. So we're going to see for ourselves. 8 plus 5 equals 18, with the remainder, which equals 9 equals 0. 6 plus 8 plus 8 plus 8 equals 30. The remainder of 3. 2 plus 5 plus 2 plus 5 plus 2 plus 5 is 14. Yeah.
Don't forget to cast out the 9s, Miss Dominique.
Yeah. So 5. So 8 plus 0 equals 8, gives us 8. So then we have 2 plus 3 plus 8 plus 2 equals 15, equals 1 plus 5 equals 6. So that's 3 times 2. So as you see here, they added all this, got 16. So 4 times 4 gives us 16. So once you cast out 9, show there's an error. The given remainder is 3 and 4. The correct answer is 23,992.
I like how you broke that down. It sounded really good.
Yeah, thank you. Question 10, Module 3.2, C through D, Miranda. Use the processes of casting out 9 to check each of following answers.
Okay. Let's get it. Okay, so problem C is going to come up. Let's say we have 78,362 minus, sorry, 33,674 equals 74,678. Sorry. So we're going to check to see if this is correct by trying to cast out our 9s. So first, what we're going to do is look through the first row. Do we have any 9s? No. Do we have something that equals to 9? Yes. We have 6, 7, 8, 9. So the 6 and the 3 get taken out. Okay, then we look at the 7 and the 2. 7 and 2 equal 9. So we're taking that out. So what it leaves us is 8 plus 0 equals 8 and gives a remainder of 8 from the first line. And then our next line, again, we're going to look at if anything equals to 9. So 6 and 3 are out, and then we have 7 and 4. So we have 7 plus 4 equals 11. When you have a double digit, you add it, and that's going to give you a remainder. So we have 1 plus 1 equals 2. So it gives us 2 as our remainder. And then now we're going to go to the bottom. We have 7, 4, 6, 7, and 8. Do any of those equal 9? Yes. So we casted them out. So what we have left is 8 plus 2 equals 10. So what we're going to do, because it's a double digit, we're going to add it. So 1 plus 0 equals 1 and gives a remainder of 1. Now we're going to go to the bottom. Now we're going to look and see if any of these are going to equal 9, and they don't. So we're going to do 7 plus 4 plus 6 plus 7 plus 8 equals 32. Now we're going to add the 3 and the 2, and it's going to give a remainder of 5. When you add this all together, it's going to give you an incomplete equation because it's not right. So the correct answer is 7, 4, 6, 8, 8. Now we're going to look at D. Now multiply. It's going to be the same principle. The only difference is with our remainders, we're going to multiply. So we have 337 times 620 equals 209,940. So first we're going to look at the first two. Any of them equal 9? No. So we're going to go 3 plus 7 equals 13. What do? It's a two-digit number, so you got to separate and add it. So 1 plus 3 gives a remainder of 4. Then we're going to go to the next one. There were none of them that equal 9. So 6 plus 2 plus 0 equals 8, gives a remainder of 8. Now we're going to go to the bottom. So we had some 9s, we casted them out. And then we had 2 plus 4, yes, gives us 6. So it's going to give a remainder of 6. Now what we're going to do, there it is. The one above it is the remainder of 4 times 8. When you multiply, you're going to multiply these two together, and it's going to give you 32. And then you're going to separate, because remember, it's a two-digit number. So we're going to go 3 plus 2 equals 5, gives a remainder of 5. When we do the bottom, it's going to give a remainder of 6. But it's an incomplete equation again, because this plus that does not equal it. It equals 208,940. So we're going to go to problem 11, question 11, module, it's going to keep on rolling. Module 3.3a through C. The color rods shown here are 1 centimeter square of a length of 1 centimeter, 2, 3, 10. We say a rod measures another rod if the end number of the first rod places end to end are the same length as the given. We're going to demonstrate it through this problem and the next one. Miss Dominique, can you help me solve it, please?
All right. So we're going to show which rods will measure the 9 rod. As you see, the 9 rod is here. So we're going to do 1 times 9 is 9, and 3 times 3 is 9. So that's our 9 rod. Our show which rods will measure the 6 rod. Our 6 is here. So 1 times 6 is 6, and 2 times 3 is 6. So we got 1, 2, 3, and 6. So we're going to use, for part C, use parts A and B to show the greatest common divisor of 9 and 6. So as we already know that 1, 3, 9, 1, 2, 3, and 6 have something in common, and that is 9. So 9 is our greatest common divisor. All right, Miranda. Question 11, mod 3.3 D through F. The color rods shown here are 1 centimeter square and of lengths 1 centimeter, 2 centimeters, 3 centimeters, 10 centimeters. We say a rod measures another rod if an end number of the first rods placed end to end are the same length as the given rod. Demonstrate parts A through G.
Okay. So our rods are going to come up. They're the same rods as before. Maybe we're going to review. We have our little 1, our 2, then it comes 3, 4, 5, and then we have 9, because 10 decided to be weird. And we have 8, 7, and we had 6, and then we had here 10 decided to be difficult. So what we're going to do is we're going to use these rods to solve our problem. Place the 10 rod and the 8 rod end to end. Measure the 18. Recall that a train is formed when one or more rods are placed side by side. So we're going to look at the factors of 18. We're going to have 1 and 18. We're going to have 2 and 9. We're going to have 3 and 6. All these together will equal 18. So then we're going to go to E. Show all the lengths of all the rods or trains that measure 18. So we know if we put 1 times 18 is going to give us 18. We know 2 times 9, 3 times 6. So again, it's going to give us that. It's going to measure 18. Now we're going to demonstrate how you might use the color rods to demonstrate the notation of great common divisors to children. Well, when we have these out, they're going to be really good to watch, because if you have an 18, you know it's going to equal a 2. You know it's going to equal, when you multiply this, it's going to be the same length. So the GCD of two numbers, R and S, is the length of the longest train or the rod that will measure both the R train and the S train.
Well, that's really neat about the train, because how you can multiply, like one by this one by this one, to get the understanding of, yes, they all match together, even by, 1, 2, 3, like when you separate it. So that's real cool.
I like the little bears better.
Yeah.
Miss Dominique, question 12, mod 3, question 4A and B. Demonstrate the use of this method to find the LCM in parts A and B in prime power form.
Y'all sure you want to know? Well, let's see. So our lowest common multiples is 48, 25, and 65. Here's our chart. So how we do this is 48 divided by 2 gives us 24. 24 divided by 2 gives us 12. 12 divided by 2 gives us 6. 6 divided by 2 gives us 3. 3 divided by 3 gives us 1. So then our next prime number will be 5. So it'll be 1. All right? Same thing you do with 25. 25 will not go into 2 or 3. All right? But it will, so you'll bring the 25s down, it will go into 5 times. 65, same thing. It won't divide it by 2 or 3. It will 5. That's a prime number, so 65 divided by 5, it gives us 13. So our prime factorization for this will be 2 to the 4th, because you have 1, 2, 3, 4, times 3 to the 1st, which you see here, times 5 to the 2nd, right here, times 13 to the 1st. So that's how you find that. Our B, our lowest common multiples are 40, 12, 44, 3, 63. Here's our chart. So you would do 40. So 40 divided by 4 gives us 10. So 4 divided by, so 2 times 2 gives us 4. And then 10, we got 5 and 2. So then 12 divided by 6 gives us 2. So you bring 6 down, that's 2 times 3. 44 divided by 4 gives us 11. You bring 4 down, it multiplies is 2 and 2. 363 divided by 3 gives us 121. So under 121 is 11 times 11. Our prime factorization is 2 to the 3rd times 3 to the 1st times 5 to the 1st times 11 to the 2nd.
Thank you for breaking that down. Those looked hard.
You're welcome. I mean, hey, Miranda, question 12, mod 3, 4C. Demonstrate the use of this method to find the lowest common multiples in part C in prime power form.
Okay, so our problem, so our lowest common multiple of 250, 28, 44, and 110. So what we're going to do is we're going to make our little chart and we're going to put our numbers at the top. So 250 is 2 times 125. 2 is the lowest. So 125 is 5 times 25. 5 is the lowest. Then we're going to come down. 5 times 5 is 25. Now we're going to move on to our next column right here. We're going to have 28. So 2 times 14 is 28. 2 is the lowest. Then 2 times 7 is 14. Those two cannot go any further. Then we're going to move on over to 44. 4 times 11 is 44. And then 11 is the lowest. So we're going to come down. 2 times 2 is 4. Again, they're the lowest. And then we're going to move over to 110. 2 times 55. 55 can be reduced down to 11 times 5, and that's the lowest. So the prime factorization, if you bring them down, is going to be 2 to the 2nd, because you have 1, 2 here, you have 2 there, you have 2, so that will all go into it. You have 5 to the 3rd, you have 1, 2, 3, 5s in the first one, so it will be good for the rest. You have 7 to the 1st, is 1, 1, 7, and you have 11 to the 1st, because each equation only has like 1 11. So that way, that's how that's going to work.
Like how you broke it down. Thank you.
I know, but yours was way cooler. Miss Dominique, question 13, mod 3.5. Oh, question 5. Okay, in a machine, a gear with 48 teeth is engaged with a gear with 84 teeth. With A and B on the small and large gears, demonstrate how many revolutions the small gear will have to make before A and B are again in the same position.
All right. Well, here is our gear 84. Here is our gear A, 48. So gear A is 84. So 2 times 42 is 84. 2 times 21 gives us 42. You bring that down, 73 gives us 21. Gear B, gear 48. 2 times 24 is 48. 2 times 12 is 24. Bring that 12 down. 2 and 6. Nothing for 2. You bring that 6. It gives us 2 and 3. So 2 to the 4 times 3 to the first times 7 to the first equals 336. And so our lowest common multiple is 336. And 48 equals 7. So the gear will make 7 rotations to end up in the starting position. Miranda, question 14, mod 3, 6. Demonstrate how to create a magic square using the following integers: -7, -6, -5, -4, -3, -2, -1, 0, and 1. Now create a magic square of your own and demonstrate how you decided on the numbers and positions of the number.
Okay, so first we need to know what a magic square is. Some people are watching our video don't, we do. But a magic square is a square arranged so that the numbers in all rows and all the columns to diagonal have the same sum. So with our equation, we're going to have to find our magic number. So how we do this is we're going to add our integers. A -7 plus -6 plus -5 plus -4 plus -3 plus -2 plus -1 plus 0 plus 1 equals -27. Now we are going to divide by 3. So -27 divided by 3 gives us a -9. And our -9 is going to be our magic number. So this is going to be awesome. So what we're going to do is 0 plus -7 plus -2 is -9. -5 plus -3 plus -1 gives us a -9. -4 plus 1 plus -6 gives us a -9. So we're doing what our definition gave us. So that is how we do our magic squares. Okay, Miss Dominique, question 15. Them gosh darn shades. Okay, question 15, mod 4, question 1a. Demonstrate how to convert these decimals as fractions of the lowest term and demonstrate how to find the prime factorization of the denominator in each case.
We'll follow, here we go. A, we have 0.225, and as you can see, they're color coordinated. So in our tens place, we have 2 over 10. Our hundreds place, 2 over 100. Our thousands place, 5 over 1,000. So you'll equal that to 2 over 10 plus 2 over 100 plus 5 over 1,000, which gives us 2 times 100 equals 200 over 1,000. 2 times 100, 2 over 100 times 10 equals 20 over 1,000. 200 over 1,000 plus 20 over 1,000 plus 500 over 1,000 equals 225 over 1,000. You break that and get 9 over 40. B, so 9 over 40 will be the 225 and the 1,000. So 9 times 25 gives us 225. Bring the 9 down, 3 and 3, 25, 5 and 5. So the 1,000 is 40 and 25. You bring the 40 down, you get 4 and 10, 2 and 2, 2 and 5, and for 25, it's 5 and 5. So you're going to do 2 to the third times 3 to the second times 5 to the third.
Ooh,
Miranda, Demonstrate how to convert the decimals as fractions in lowest terms and demonstrate how to find the prime factorization in the denominator in each case. Question 15, mod 4.1b.
Okay, thank you, Ms. Dominique. Okay, so our equation is B 0.036. So we're going to have to make this a fraction. What we're looking for is the places. This is how we're going to do it. We have 3 over 100. And then we're going to have 6 over 1,000 because it's after the 0. So it's going to be 1,000 instead of hundreds and thousands. And so what we're going to have to do is find our common denominator. We have 100 and then we have 1,000 over here. So what we're going to have to do is we're going to have to times 100 times 10. And then that'll give us 1,000. Then we're going to have to do the same thing we do from the bottom, we do to the top. So we're going to go 3 times 10 gives us 30. So then we'll have 6 over 1,000 and we'll have 30 over 1,000. And we're going to add it together and it's going to give us 36 over 1,000. Now we're going to have to divide down to simplify it out. And so when we divide it down, it's going to give us 9 over 250. That's the lowest it's going to go because both of them can divide by it. Now we're going to come down and we're going to find the prime factorization. So we have 36. We're going to do 2 times 18 equals 36. Then we're going to come down and we're going to go 2 times 9 equals 18. And then 9, we're going to go 3 times 3. And then we're going to come over here to 1,000. We're going to do 2 times 500. And then we're going to come down and do 2 times 250. We're going to break 250 down to 5 times 50. We're going to break 50 down to 5 times 10. And we break 10 down to 2 times 5. And this is going to give us 2 to the third, to 3 to the second, to 5 to the third. And if you notice the little red spots right here, it's because it's the lowest it can go down. And that's how we have 9 over 250. It's really cool, and this adds up to that.
It is. It really is.
I love the colors, Miss Dominique. You do so good at the colors.
Thank you. It's like a little easier because the pop, so you'll know what numbers that you're talking about and where they're actually at.
They relate very nicely. So we're going to go to question 16, mod 4, question 3. Demonstrate the percentage and fractions of each red portion of the figure, Miss Dominique.
So as you see, we have our figure here, and this figure is a square. So what we have shaded is one shaded area, okay? So it's going to be, our fraction is going to be 1 over 5 because we have a shaded area. So then we'll count the other ones, 1, 2, 3, 4, and 5. That's how we got that. So to do the percentage, we're going to do 1 over 5. So that'll be 0. You break it, 0.2 times 100. That's going to give us 20%. Our next one is we have 1, 2, 3, 4 shades. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0.4 times 100 will give us 40%. So our circle here, we have one area shaded and the other one's not. So that's going to be considered 1/2. So it'll be 0.5 times 100, and that's going to give us 50%.
Good job. Them fractions can be hard.
Yeah, they really can. Miranda, question 17, mod 4.4. The area of the yellow hexagon is the whole. Then the remaining pattern blocks have areas that are approximately 16.6%, 19.2%, 33.3%, 38.5%, and 50%.
Okay, so what we're looking to see is if these shapes will fit into our hexagon. Ooh, it's really dry outside. So our hexagon is gonna represent our whole. We're gonna see if they're gonna fit in. So this represents 100%. So our next shape we're gonna look at is a triangle. We're gonna realize how many triangles can we fit in there. When we do it, it doesn't fit very well. So we only have 16.67%. Now the next shape we're gonna try to fit into our hexagon is a tan rhombus. I thought this was a diamond. Apparently now they upgraded to rhombus, so a tan rhombus. And so what we're going to find is only 19.2% will go into our hexagon. Now our next shade is a blue rose. Again, I thought it was a diamond, but it's just a sideways one. So we're going to see how many is going to fit in here. And our percentage is going to come to 33.3%. So maybe if you put it in a flower pattern, it might fit in there better. And then our next we're going to look at is our square. Now our square, we can get quite a many squares in there. And we're going to have probably about 38.5%. And now our last one that reminds me of the dominoes, like Pizza Hut top on there, is a trapezoid. I did not know that was a trapezoid. I just thought I was just calling it the, pizza symbol. But we actually can get 50% because two of these will make a whole. So we're going to go to question 18, Miss Dominique, and it's going to be Mod 4, question 6. Create a proportional reasoning scenario, then create a table and a graph to show the rate of your proportional change.
Okay, we are driving to Disneyland. We stop at 224 miles and pump 8 gallons of gas. The next stop was at 280 miles and pumped 10 gallons of gas. The last stop, we drove 112 miles and pumped 4 gallons of gas. How many miles, K, did we get from 1 gallon of gas? Well, as you can see, we have our gas gallons and our miles. So we got 8, 10, and 4. And our miles is 224, 280, and 112. So we got A over B equals C over D. 8 equals K over 224 times 1. So AD equals BC. So that's, if you cross multiply, that's 8 times 1 equals 224 times K. So 8 divided by 224 equals K. So K equals 28. The car travels 28 miles for every 1 gallon of gas. All right.
Miss Dominique, I like how you broke it down into equation form.
Yeah, it made it look easy. Well, this is the end of our final team teach, and we just thank you for watching. Until next time. Bye.
Bye, y'all. Thank y'all for watching us.